Consider the reaction H2 plus O2 becomes H2O, right? In the tip of like a cup pipette. So like this is my pipette right here. When the reaction occurs inside here, there's a bunch of energy and some water that's produced, right? And the water, I'll do it in blue. And the water is going to shoot out from here, and that's going to propel my pipette up. So what will be the best amount of hydrogen gas and oxygen gas to mix to get the maximum distance? Would it be 1-to-1 ratio? Maybe a 2-to-1 ratio? Maybe a 1-to-2 ratio, right? We can know, or we can figure out what the ideal ratio would be. So the ideal ratio would have to be using balanced chemical reactions. So we know that 2H2O plus O2, 2H2 plus O2 becomes H2O, right? And 2H2O. Okay, so we know that balancing chemical equations and having balanced chemical equations are super important, right? But what does that have anything to do with the redox unit? Well, we have to be able to balance redox equations, and they aren't, I'm going to be honest, most of the time they aren't as simple as balancing regular equations. So let's get right into it. So basically, in essence, the steps, there are just 4 main steps to balancing redox equations, right? And it doesn't seem that hard, and there are a couple special occasions, just like everything with chem, but it'll be pretty easy, I guarantee. So the very first step is going to be breaking down the equation into half equations. Right now, if you don't understand what a half equation is or anything like that, don't worry, I'll define everything later. Okay, and then the step 2 is balance half equations separately, right? Half equations. So you want to balance them separately. Then we're gonna equalize the electron count. And this is because, remember, redox is following the movement of electrons from one chemical to another, right? So we want to be able to say that the electron movement is what's causing whatever's happening, right? And so we have to say full amount of electrons move. We can't just say like, oh, half of an electron moved, or like we only moved 2 electrons, but we ended up with 3 electrons in the other one, right? The law of conservation says this. Okay, and the very last step is actually the easiest step. Add, right? And this is going to be using what's basically Hess's law. So in essence, these aren't really hard. Maybe the only thing that's a little confusing is what is a half equation, right? I said it twice, but not everyone's familiar with it, right? Don't worry, I'm going to define it later when we go over a couple questions, practice questions. So don't fret. We do have a couple of exceptions. That's in acidic versus basic conditions. Actually, let me color code them, because colors, basic conditions, right? Okay, so when we're dealing with acidic conditions, so whatever's in black is going to be our very base. We're going to do them every single time, right? However, in acidic conditions, balancing the half equation is going to be broken down into a couple more steps. So A1 for acidic 1, we're going to keep basically the main steps, right? So we're going to first break them down into half equations. Then what we're going to do is we're going to balance all elements except H's and O's. So that means hydrogens and oxygens, right? Then to balance oxygens, so that's going to be A2. To balance oxygens, we're going to add water, H2O, to balance O's. A3 is going to be add hydrogens, add H's, to balance out all the waters, right? And then we're going to go back, equalize the electron count, and add using Hess's law. Okay, then let's consider it in basic conditions, right? Once again, everything's going to be the same, but there's only going to be a little extra. So basically, what bases are going to do is what the bases are going to do is it's going to be the exact same. We're even implementing all of the exact same. Right, it's going to be the exact same, implementing all of this as well. There's only going to be just a little bit of another thing. So right after adding all of our H's, normally we went right back, right? Instead of that, we're going to have B1 for base 1, first additional step in bases. We're going to add OH to both sides, OH minus to both sides. And this is going to neutralize our remaining H pluses. Remember, basic conditions instead of acidic conditions, and freestanding hydrogen ions are going to contribute to a acidic condition. And then B2 is going to be combine H plus OH minus to make H2O, right? And then after that, we're going to balance our electron count and add using Hess's law. Okay, so this is basically everything that you do have to know, right? And if you completely understood all of this, you can probably stop watching the video now, but practice is always really important. So let's practice some. Okay, so now we have let's actually do a regular redox equation with nothing special. So say we have zinc metal plus silver ions becoming zinc ions, plus 2, and silver metal, right? So this is going to be solid, aqueous, and solid, right? Okay, so I mean, this looks ridiculously easy, right? This is so easy, but we should first make sure we get all of our basic fundamentals down. Not basic as in the chemistry basic, but basic as in simple. Our fundamentals down before we deep into the 6 feet deep water. So let's look for half equations. So first off, what is a half equation? So I'm just going to define that up here. Half EQ. It's basically just chopping the equation in half. Gleaning our important conditions, I suppose. Right, this is a really terrible definition, but basically in redox, we're going to be cutting our full main equation into an oxidizing reaction and a reducing reaction. Okay, so let's go back. So we're going to have an oxidizing O and a reducing R. Okay. To figure out which is which, we're going to have to assign some oxidation numbers. So assigning oxidation numbers, I'm just going to gloss over it really quickly because we have done this before. If you are a little confused or anything like that, refer back to my channel. You'll see like an intro to redox that you can use. Okay, so we're just going to go really quickly over it. Zinc is 0, Ag is +1, zinc is +2, Ag is 0. Okay, so now let's figure out what's reducing and what's oxidizing. So zinc is going from 0 to +2, right? And I always like to have Leo-Ger written just because I can look at it. So it's getting more positive, so it's losing electrons. So we know that zinc is being oxidized because it's losing electrons. So we're going to have zinc becomes zinc +2. And that means that we have silver. Silver is going from plus 1 to 0, so it's getting more negative, which means it's being reduced. So Ag plus becomes Ag. Yeah. Next, I'm going to be doing only the oxidized, sorry, I should have color coded this. I'm going to be only doing the oxidized like in depth, and I'm going to be leaving the reduction for you guys to try, and then you can check with me later, check our answers later. I mean, I'll still do them, but I won't do them as thoroughly as I would with zinc, or with the oxidizing. That's going to be common throughout the entire video, I think. So let's do it. So zinc is, I mean, it's really easy. We know that we can see that. Sorry, let me just point it out. We can see that our elements aren't, not balanced. So all we have to do is balance out the electron count. And just to do that is, since we have 0 total charge here and plus 2 total charge here, if we do plus 2e minus, then we have our total electron count. Okay, that's super simple. I want you guys to try, the reduction on your own. It's actually pretty simple. So pause the video now and give it a try, and whatever. Alright, so hopefully you guys gave it a try. Yeah, it's just gonna be E minus here, right? And then now what we have to do is basically apply Hess's law. So we're gonna be trying to be adding up these equations, right? And to add them up, since I told you earlier that electrons, have to be the same amounts, notice how this is the whole balancing electrons out part. Notice how we have only 1 electron here, but we have 2 electrons here, right? To go from here to here, though, we still need the 2 electrons. So we're just gonna multiply everything out here by 2, and then we're gonna have that zinc becomes zinc plus 2e minus. We're gonna have 2e minus plus Ag plus, or 2Ag plus becomes 2Ag, and then we're gonna cancel out whatever's common, and we're gonna eventually simplify to zinc plus 2 silvers becomes zinc plus 2 silvers. Okay, so super simple, right? It's actually not that hard at all. Now let's go over, the special cases, the one in acidic conditions, and I'll do one in basic conditions. So these are a little harder, I would say. Definitely trips up more students just because you have a couple more steps to memorize, but once you do memorize the steps, it's actually super easy. So let's consider the equation MnO4 plus Zn becomes MnO2 plus ZnOH4 2 minus. Okay, first things first, let's assign our oxidation numbers. Well, we know that O2, or O, is always minus 2. This means that we're going to have plus 7 for manganese. We're going to have 0 for zinc. We're going to have minus 2 again for oxygen. We're going to have another minus 2 here and a plus 1 here. And then that's going to give us plus 2 for zinc. And then for manganese, we're going to have, was that plus 4? Yeah, that looks about right. Plus 4. Okay, now let's figure out our half equations. So what's being reduced? What's being oxidized? Well, sorry, I can't find my colors. Here it is. Well, let's look at this. Zinc is going from 0 to plus 2. And if we refer back to our good old friend Leo Ger, we know that zinc is getting more positive, aka losing electrons. So we're going to have zinc becomes zinc hydroxide 2 minus. And that means that, sorry, I didn't color code it. Hopefully we can kind of keep it straight in our brain. Actually, you know what? I'll color code it just because I care about education so much. Zinc becomes zinc hydroxide 2 minus. Okay, and then that means that the only other element that's changing is our manganese. So this must be our reducing. So MnO4 minus becomes MnO2. Okay, and remember we are doing this, actually I should have titled it.
we are doing, let me do it in Thanos color. We are doing in acidic conditions. Acidic conditions. Okay, so once again, I'm gonna very thoroughly go through my oxidation stuff, and then you guys can try the reduction, and then I'll walk you through it again. So first off, zinc becomes zinc hydroxide 4,2 minus. Okay.
Looking at it, the zincs are fine, so that's okay. Next, we're gonna. Sorry, let me move this a little bit. So next, we're gonna look at our oxygens and balance out our oxygens. Because oxygens are easy, right? We just have to add water. Notice how we have 4 oxygens. Therefore, we're gonna add 4 waters. 4H2O.
Okay. Now we have 8 hydrogens here, and we only have 4 hydrogens here. So we're gonna add plus 4H plus. Okay. So far, so good. 4H plus, 4H plus. Now what do we have to do? We have to balance out our electrons. We have 0 total charge here, and we have a total charge of plus 2 because we have a 2 minus from, because we have a 2 minus from here and plus 4 from here. We are going to have a total of 2 plus 2, so we have to add 2 electrons, 2e minus. Perfect. That is our oxidizing side fully done. Okay, now let's try our reducing side. Hopefully you guys are going to give it a try. You're going to pause right now, you're going to work it through, and then I'll get back to you. Okay, hopefully you've done it. Now let's do it together. MnO4 minus becomes MnO2. Balance out our waters. We're going to have to add 2H2O here. That means we're going to have plus 4H plus here. Balance out our electrons. 3E minus. Did you get it? Hopefully you did. Okay, now it's going to go right back to what we were doing earlier. We're going to multiply this whole thing by 2, this whole thing by 3, right? And then we're going to apply Hess's law. So that's going to be 12H2O plus 3 zinc becomes 3 ZnOH42 minus plus 12H plus 6E minus. And then it's going to be 6E minus plus 8H plus 2MnO4 minus becomes 2MnO2 plus 4H2O. Sorry, O. We're gonna cancel out what we can, and then we're gonna simplify. So instead of 4 here and 12 here, it's gonna be 8 here total. Instead of having 8H plus here and 12H plus here, it's gonna be 4H plus there. And everything else should be fine. So what we're gonna have is 8H2O plus 3 zinc plus 2, I think it's manganate. O4. Sorry, I've been avoiding saying it because I'm not super sure. And then I think this is permanganate. Not super sure though. Don't quote me on that. 2MnO2. Clearly, I have some memorizing to do too in chemistry. Zn. Oops, sorry, I forgot my coefficient. 3ZnOH42 minus plus, running out of space, plus 4H plus. So there it is in acidic conditions. And let's move on now to basic conditions, right? Acidic conditions was not that bad. It was really easy. It was actually pretty simple, I'd say. I guess the hardest part would be remembering to add the waters and hydrogens, but should be fine. Now let's move on. I want to use a different color. I don't want to use orange. Oh, I have green. Okay, now let's move on to basic conditions. So basic conditions. Just for simplicity's sake, so that we can kind of compare what's happening, I'm going to use the same exact equation. So that's going to be MnO4 minus, which I swear to you is manganate, plus zinc. It was MnO2, which I think is permanganate. Might be hypomanganate. I'm not super sure. Sorry about that. I still have my polyatomics to memorize. 2 minus. Right, and then we're gonna, do basically the same thing, and I'm gonna really rush over this. I do recommend, give, hopefully I didn't erase. I didn't. Give like until step like A3 a try by yourself. So step A3 is right there. Give that guy a try by yourself, and then because I'm not gonna do it again, I'm just gonna skip right over to it. So definitely give it a try, and hopefully you'll get it. So pause the video now, give it a try. It's running a little long, so I am gonna sort of rush through things a little. So now in this case, we're gonna have hopefully you did try it. Pause now if you didn't. I really recommend you try these. These you have to just kind of memorize these. Okay, so we're gonna have 4H2O plus zinc, or sorry, not plus. Zinc becomes zinc hydroxide 2 minus plus 4H plus, right? We had this from before, and if you need to see how I did it, just go back like a couple minutes and you'll probably find it again. And then in the reduction side is 4H plus MnO4 minus. I keep wanting to say plus even though it's, sorry, that's a little messy. MnO4 minus becomes MnO2 plus 2H2O. Okay, so now this is where things start to get a little funky, but we got this. I'm going to work on the oxidation side again as usual, give the reduction side a try after you watch my example, and then we'll work through it together. Okay, so very first thing is now we have to, because we are in basic conditions instead of acidic conditions, we don't want to have any free-floating hydrogen ions, because remember, hydrogen ions lead to acidic conditions, and we see that we have a hydrogen ion right there, right? So we want to get rid of that. How are we going to get rid of that? By adding hydroxides to either side, and we have to add hydroxides to both sides. OH minus, because we don't want to change the equation in total, right? We're just trying to, it's like adding a number on both sides when you're doing like algebra, right? Like x plus 2 equals 3, right? You know how we subtract 2, subtract 2? That's the same idea right here. So yeah. Okay, so the next what we're going to do is we're going to combine any free-floating H's and O's that we see. So that might be a little confusing, so I'll highlight it for you in pink. These guys can add up, and remember, because from the pH unit you might be trained to think that H2O is H2 plus O2, right? I opened with that, but another way you can think about it is it's H plus OH minus. Okay, so we're gonna add those together, and I'll denote that in a different color just so that you can kind of remember that I did do that. I'll denote that in, man, I am running out of colors. I'll denote it in a lighter blue. So we're gonna have 4H2O, because remember we had 4H plus and 4OH minus. 4H2O here, right? And so that should be almost fully done. Now we just have to balance our electrons, right? So I'm gonna go back to the regular blue, balancing our electrons. So we had minus 4 here, and we only have minus 2 here. So what do we have to do? We have to add 2E minus. Okay, now this is super long and super kind of just unwieldy, right? So let's figure out, can we cancel anything? And you will find that we can cancel something. We have 4H2O here and 4H2O here, so those can cancel out, leaving us with a nice, a lot tinier of an equation, right? And a lot tinier too, tidier and tinier. So let me just move these over so that we can see it as one. Unity is so important. So let me just move them over, and boom, right? It looked really big, it looked really challenging, but in reality it was so simple. Okay, want you to give the reduction side a try on your own. Yeah, so pause right now and give it a try. Did you try it? Hopefully you did. So let's work on it together. If not, I really want you to try these so that you're not, shooting yourself in the foot later. In a video game, of course. Don't shoot yourself. That's bad. Okay, so then we're gonna have to neutralize our acids. So add 4OH minus on this side, 4OH minus on that side, and now we make our waters. These guys connect. Please tell me there's a darker red this time. Oh my goodness, you cannot tell that I changed the color. I mean, we really don't need to know that I did change the color though, I guess, so it's fine. Plus MnO4 minus becomes MnO2 plus 2H2O plus 4OH minus, right? I'm not sure why I rewrote it when I could have just manipulated my first equation, but c'est la vie, such is life. So I guess this is the way the cookie crumbles. Okay, next we're gonna balance our electrons, right? We have -1 here, -4 here. So we're gonna have to add more electrons on this side, right? Pretty simple, pretty self-explanatory. I lost my stick for 1. Oh no. It's a tragedy. Okay. So balancing the electrons means that we're gonna have to have 3 E minuses here. Okay, see if we can cancel anything, and we can get rid of this water here, and this water now becomes, we get 2 waters here now. And then the final step, you should be able to do on your own. What is happening? You should be able to do on your own. If not, it's, remember, it's just adding up everything together. So we just basically do Mach Hess's law. And we get that basically. Oops. If we do why is this not working? Okay. If we do Mach Hess's law, we can notice that it's gonna be, we have to multiply this guy by 2, multiply this guy by 3. Then we're gonna get 12 OH minus plus 3 zinc becomes 3 zinc hydroxides plus 6 electrons. And on the bottom, we're going to have 6 electrons plus 4 H2O plus 4 H2O plus 3 MnO4 minus, sorry, I'm getting confused, minus 2 MnO2 plus 8 OH minus. I was getting confused. I was worried I lost waters on this step, but I forgot that I could cancel out all my waters. Okay, and then we're gonna cancel more stuff out. 6, 6. We're gonna have no waters here, no waters here, but we do have 8 hydroxides here, so it's gonna be 4 hydroxides there. And that should mean that our final equation is now gonna be 4OH minus plus 4H2O plus 3 zinc plus 3 manganate OH4. Is it permanganate? I'm so sorry about not knowing. It's so unprofessional. 3 zinc hydroxides, 4, 2 minus, and I'm just going to write this down here because I am running out of space, plus 2 MnO2. So that was balancing redox equations. Hopefully this video, helped out at least a little bit. Sorry, that was me just putting my pen away. Hopefully this video helped out a little bit, and good luck. Bye bye.